Let's look at the three wireless transmission methods that are more commonly in use today with wireless networks. Now, wireless devices use one of three transmission methods that are based upon the 802.11 standard they implement. The three primary methods are DSSS, FHSS, and OFDM, and we'll talk about all three of those and dispel the alphabet soup that they are. First of all, there's Direct Sequence Spread Spectrum, or DSSS. Now, most wireless LANs that are in use today, especially the home networks and stuff, use spread spectrum technology for transmission. And DSS is the most commonly used, and it's used in all the 802.11b wireless LAN radios. So if you're using 802.11b, you're using DSS normally. There's also frequency hopping spread spectrum, or FHSS. Now, FHSS is not used as widely as DSSS is. In fact, they do not interoperate. Now, you will have occasionally a device that's compatible with both, but it basically implements different technologies on both its transmitters and receivers that can talk to both. But it's impossible to have an FHSS and a DSS device that talk to each other. They have to be compatible with both in order to talk to each other. Now, how this works is FHSS transmissions normally jump between several frequencies at a predetermined rate or interval, so they span frequency spectrums. Now, the third method that wireless networks use for transmission is called orthogonal frequency division multiplexing, or OFDM. It's primarily used by 802.11a and G networks. Okay? It transmits data on multiple carrier waves. Now, each one of these waves carries a small part of the message, so you need all the waves to go through the way they're supposed to for the entire message to get through. Now, you might be asking, which is better, the spread spectrum technologies or OFDM? Well, it depends on what your use is, what you need it for. FHSS and DSSS are each able to easily penetrate walls, they're less prone to interference, and they offer coverage over great distances. They're more often used when you have wireless networks that need to transverse between multiple floors of a building or between two adjacent buildings, when you need to be able to penetrate walls and need distances. Now, on the other hand, OFDM offers a higher data rate over a smaller bandwidth. It also offers better resistance to interference from outside factors, and there are more non-overlapping channels. So OFDM and 802.11a and G that use OFDM are not as susceptible to getting interferences from devices such as other electrical devices that use that 2.4 gigahertz spectrum, as 802.11b is prone for. Those are just a few of the advantages between those various transmission methods.